Hi everyone, my name is Audrey, and I would like to talk to you guys about cellular respiration, a process with a backup plan. So let's get to it. Starting from the basics, all eukaryotes experience cellular respiration. Where? The mitochondria. You might have learned this as glucose plus oxygen equals carbon dioxide and water. Now this is a complicated process, but let's start with what ATP means. ATP is pretty synonymous with energy. It's what your body needs for it to carry out tasks and for your body to function. Now these are the steps that involve ATP as a product, but let's start with the beginning, glycolysis. Now this is the molecule for glucose, but let's just simplify this to the 6 carbons. These 6 carbons go through energy investment and energy harvest phases, shown in the animation right now. Energy is added and taken away as phosphates get added and taken away, until we get to 2-pyruvate acid. Overall, we can see that there were 4 ATP total that were made through glycolysis, but we should also look back to the beginning where there were 2 ATP used. Therefore, 4 minus 2 equals 2 total ATP. Now we can move on to aerobic respiration, or process that involves oxygen. This is 3 total steps shown in this diagram, but let's start from the beginning with pyruvate oxidation. We can see that the pyruvate from earlier now takes away 1 carbon and adds a coenzyme A to make acetyl coenzyme A. Plus we know from earlier with the 2-pyruvate acid, this whole process happened twice, so that's 2-acetyl coenzyme A. Now we can move on to the Krebs cycle. Acetyl coenzyme A plus oxaloacetate slowly breaks down the carbon into NADH, ATP, and FADH products until the cycle happens twice. That means 2 ATP. So again, Krebs cycle makes 2 ATP. Now, move on to the final step, oxidative phosphorylation. This step creates the most ATP of all the steps using NADH. Earlier we saw NADH in the glycolysis and Krebs cycle. This NADH is used for its H+, which goes to the outer transmembrane. This creates a concentration gradient where the above has more H+, so it has a higher concentration, which ends up wanting to go to the low concentration area. The ATP synthase uses this concentration gradient of high to low to then make 26 to 28 ATP with 26 to 28 cycles. This is of course the most out of aerobic respiration. But now let's focus on anaerobic respiration, with an environment without oxygen. Since we're running out of time, we as humans do lactic acid fermentation, which means 2 ATP are added. Big takeaway is that your body has a lot of ways to give you energy, so just know that your body is always working overtime to keep you smiling. Anyways, thank you for watching. I'll see you all later.